Okay, so we want to be able to use our new information with inverses to be able to solve a system of equations. To do that, we have to be able to write what's called a matrix equation. And so we're going to show you how that works. Now, we've worked with systems of linear equations, so I'm going to write one. Won't be too exciting. Okay, so that's a system of equations. We worked with those in 7.1, and then we had 3x3s in 7.2. And we had methods to solve, right? We used addition method, and we used substitution. And when we had the 2x2s, we actually did some graphing with them. Okay, so those are the methods we've studied in the past. And there are more methods, but we're just going to focus on one with the matrices, and that's going to be the inverse method. Okay, so what we have to be able to do is convert our system to what's called a matrix equation. So we're going to have three matrices. We're going to have A times X, and it's going to equal B. And these are all matrices. Now, X is like a capital X there, okay? So we usually identify matrices with capital letters. Okay. A, that's going to be called the coefficient matrix. B, or X, sorry, capital X, is called the variable matrix. And B is going to be called the constant matrix. Okay. All right. So, I'll show you how to get these. So for the A, the coefficient matrix, that is going to be, you're just going to pull off these coefficients. 3, 4, 6, -2. And that would be called the coefficient matrix, and that's A. Now, in order to do any of this, you have to have everything lined up. You have to have the X's terms in one column, you have to have the Y terms in one column, you have to have the equal sign, and then you have to have the constants in one column. Now, we've seen that before when we were using the elimination method, or the addition by addition method. We had to have that as well, so that we had like terms together. But just make sure, like when you go to pull off your matrix equation, that everything's lined up. Okay, so that's matrix A. That's the coefficient matrix. Matrix B, that's the variable matrix. Now, it's going to be one column. It's going to be X, Y, because those are our variables, right? Okay, so what happens here is you have a 2x2 matrix here, and here you have a 2x1. That means they can be multiplied, 2 times 2, we can multiply them, and then we're going to get an answer that's going to be a 2x1. Oh, you know what? I did it again. It's not B. That shouldn't be a B there. It should be an X. That's the variable matrix. I kept just putting a B in. All right. So now we're going to have C. C is the constant, not C. It's B. See, it's throwing me here, these letter changes. Okay. So B is going to be the constant matrix, which is going to be 2x1. In this case, it's going to be 5, 11. Okay? So when we go to write the matrix equation, we write AX equals B. So the coefficient matrix, which is 3, I really wanted that in orange, which is 3, 4, actually I wanted it in black, but that's okay. I'll live with the orange. Then we have the variable matrix, X, Y, and this all equals the constant matrix, 5, 11. So now we've written the system that they gave us, and I made up, and we wrote it as a matrix equation. Now, why does this work? Well, if you took this row times this column, you would get 3x plus 4y, right? And then if you took this row times this column, you would get 6x minus 2y. Now, that's a matrix like this, and it has to equal 5, 11, that matrix, right? So you get the equation, like if you took it out of a matrix, you would say, oh, 3x plus 4y has to equal 5, and 6x minus 2y has to equal 11. That was what we started with. Okay, so we're back to where we started. So that's why it works. We have to have a coefficient matrix, a variable matrix, and a constant matrix. Okay, so that's how you make a matrix equation. Now, what about solving? Well, remember back in the old days when you had something like 3x equals 15. And so you said, oh, I'll divide both sides by 3, or I'll multiply by 1/3, the inverse, right? So that 3 to the negative 1 times 3 times x. This became just 1x, and then over here you had 5, so you had x equals 5. Now, you know, you've done so much of that, you probably just said, I'm going to divide both sides by 3, and you get the answer. Okay, so how does it work with matrices? Well, we have a matrix equation. We just discovered how to do that. And what we're going to do is we're going to multiply by the inverse. Now remember, matrix multiplication is not commutative. So I'm going to put it in front here. And I'm going to write it like that. So I put it in front on the left. I have to put it in front on the right. Okay? So now I'm multiplying both sides by the inverse, as long as it's not 0, and it's not because it's an inverse. Okay, then I can do that. So I multiply both sides by the inverse, just like what we did back in the old days with real numbers and equations. Okay, now matrix multiplication is associative, so I can make this A inverse times A times X. And then what is an inverse? You know, what is A inverse times A? Well, that's the identity matrix, right? But what's the identity times X? Well, that's X equals A inverse B. And so you have your variable matrix equaling whatever this is. Okay, so that's the idea for solving the system. So we're going to show you with a 2 by 2, and then we're going to show you with a 3 by 3.